We're going to start today graphing rational functions. In the last lesson, we found out how to find vertical and horizontal asymptotes, and those are going to be key parts of our graphing steps. We're going to go through 6 steps in order to graph these. And step 1, all you need to do is find the domain. And to find the domain, you just set the denominator equal to 0. And the domain is all real numbers except for those values of x that make the denominator go to 0. So I'll just say the denominator cannot be equal to 0 for the domain. In the second step, you're going to find the intercepts. And if you remember, the x-intercept is when y equals 0. And all you have to do with the x-intercept is set the numerator equal to 0 and solve for x. And then for the y-intercept, all you're going to do is let x equal 0 and simplify the result. So you'll get a couple of points, or you might get 3 or 4 points. You might get multiple x-intercepts. Usually you'll only get one y-intercept. In step 3, you're going to find holes in the graph. My first few examples, we won't have any holes, but a hole in the graph is found like this. You factor the numerator and denominator, and if there are any common factors, in the form of x minus a, then x equals a is a hole in the graph. And I'll show you what that looks like in a few more examples. But the first few, we won't have any holes. Step 4, you're going to find the asymptotes. And I described how to find the vertical and horizontal asymptote in the lesson before this. So for the vertical, you set the denominator equal to 0 and solve for x. For the horizontal asymptote, you're going to compare the degrees of the numerator and denominator and go through the rules. So when you find the asymptotes, you're going to sketch them as dotted lines. And then you're going to find a couple of additional points on the graph in step 5. Find a few other points. And I'd like you to get the x values or the points just to the left and to the right of any vertical asymptotes that you found in step 4. And then step 6 is just to sketch. So this is all best done with a specific example. We're going to start out with the example f of x is equal to x over x squared minus 4. So step 1 says the domain If you set the denominator equal to 0 and solve for x, you'll get the domain is all real numbers except for plus and minus 2. Step 2 is finding the intercepts. If you let the numerator equal to 0, you'll find the y-intercept or the x-intercept. So 0 over, well, let's let x equal 0. So 0 over 0 minus 4 is f of 0. When you let x equal 0, you're finding the y-intercept. So the y-intercept is equal to 0. The x-intercept is when you let the numerator equal to 0, be equal to 0. So the y-intercept is 0 and the x-intercept is equal to 0. 0, 0 is the intercept on this. The only intercept is the point 0, 0 or the origin. Oops. Step 3 is to find holes. Well, there are no common factors in the numerator and denominator, so there aren't going to be any holes in this for step 3. Step 4 is find the asymptotes. First, we'll find the VA. Excuse me. The vertical asymptote is a line, and you let x equal what the domain, what values are not in the domain. So x equals 2 and x equals -2 are the two vertical asymptotes on this. The horizontal asymptote is you compare the degree of the numerator with the degree of the denominator. And since the numerator is less than the denominator, that means the horizontal asymptote is the x-axis, so y equals 0. And then the next step is to find a few other points on the graph. So let's just start sketching these asymptotes, and we can figure out what points we want to the left and to the right of the vertical asymptote. So here's our xy axis. And you're going to sketch these asymptotes with dotted lines, so you can just a little bit above the x-axis. You're going to put the dotted line and label it y equals 0, so it's clear that that's the horizontal asymptote. The vertical asymptote, here's x equals 1, x equals 2, -1 and -2, so you can dot these and label them x equals 2, x equals -2. So there's the two vertical asymptotes. And this has one x and y intercept, and that's the origin, so you're just going to put a point at this origin. And then the other points you want to get just to the left and to the right of each one of these vertical asymptotes. You want to find f of 3, f of 1, we already know f of 0 is 0, f of -1, and f of -3. So we'll just set up a quick xy table and let x equal -3, -1, +1, and +3. So when you plug in x equals -3 into the original function, you get y equals -3/5, x equals -1, y equals 1/3, x equals 1, y equals -1/3, and when x equals 3, y equals +3/5. So, be quiet. So you're going to plot those points over on your graph. -3, -3/5, -1, +1/3, +1, -1/3, and +3, +3/5. And so I know the only x-intercept that this has is the origin. So what this graph is going to do, because of vertical asymptote, the graph gets closer and closer and closer to it without crossing over. So it's going to infinity in this direction. I knew it wouldn't go to infinity in this direction because then it would have to have another x-intercept. I know it's going through the x-axis here at the origin, and then I know it's going through this point, and this vertical asymptote, this graph must be going down here because it wouldn't cross over the x-axis again. Over here, because you have a vertical and a horizontal asymptote right here, this graph isn't going to cross over it. It's got to go in this direction. It couldn't go down. It couldn't go over that x-axis again. And here is the horizontal asymptote. So there's that part of the graph. And over here you have the same situation in reverse. You're going to be getting closer and closer to the x-axis in this direction, closer and closer to the vertical asymptote in this direction. So there you have your first rational function graphed. The next thing that we're going to graph really quickly, hopefully before the next bell rings, is f of x, second example, f of x is equal to 2x squared minus 7x plus 6, all divided by x squared minus 3x minus 4. Be quiet. So what you're going to do is you're going to set the domain. The domain is all real numbers except for what makes that denominator equal to 0, which is x equals 4 and x equals -1. You're going to factor the numerator and denominator completely, so this becomes x plus 1, x minus 4, and this numerator factors into 2x minus 3 times x minus 2. There are no common factors, numerator, denominator, so there aren't going to be any holes. There's going to be a vertical asymptote at x equals -1 and x equals 4, so there are going to be two of them. You're going to have a horizontal asymptote because the degree of the numerator is equal to the degree of the denominator, so you're just going to divide the leading coefficients. Y equals 2. You're going to have some x and y intercepts. The x-intercept is what makes the numerator equal to 0. And what makes the numerator equal to 0 is x equals 3/2 and x equals 2. So you have two x-intercepts on this. And the y-intercept is in the original function when you let x equal 0. Everything goes to 0 except this positive 6 and the -4. So the y-intercept is y is equal to 6 over -4, which is -3/2. And so now we're ready to set up our graph. And I have a feeling that the bell is going to ring pretty soon. So I'm going to cut this off and we'll continue this later. Hopefully you took some good notes.